Geotechnical engineers, they always go in beast mode.
Beast mode. Go beast mode.
Beast mode in design, beast mode in politics, and beast mode in the field. When they feel comfortable, I know that makes me feel comfortable. And if I look in the eyes and they scared, then I know I better be scared. They keep me safe, they get my building complete, and they're the ones who are the unsung heroes. Geo. Welcome back to Breaking Down the Development Pro Forma with your host, Eric Brody. We're on episode number 3. Episode 1, we talked about an acquisition, how you're going to acquire the asset. Episode 2, we talked about the design and the artist, the architecture. Episode 3, it's time to break it down and go below grade, under the surface. And we're going to talk about the geotechnical engineers, so sit down and pay attention. If you've ever actually developed a building, and I don't mean underwrote, and I don't mean sat in an office, I mean got off your tush, went down to the site, and got into the pit, you know there's no way out of the ground if this person isn't on your team, and that's the geotechnical engineer. They are the unsung heroes of the game. And why are they the unsung heroes of the game? As you learn in Construction 101, there's 2 things that you can never know when you're in your underwriting, and we're going to talk about that later. Number 1, what's behind the wall, unless you probe it and demo it. And number 2, what's below the ground. So the unsung heroes, they don't get any awards. There's no starchitecture as the geotechnical engineer. And the better they are, the more confident they are, and the more experienced they are going to save you in your project. All right, we spoke about it. But what does a geotechnical engineer even do, right? What is a geotechnical engineer? It's an engineer that has to understand geological conditions, the different types of performance of dirt, how water is absorbed, water tables, rock, and how your building, the weight of the building, will interact with the earth so that it doesn't have differential settlement, which is like the Leaning Tower of Pisa. All right, so what are the core responsibilities? We now understand that they understand the below grade conditions, but what are the core responsibilities? In urban construction, they have 2 main responsibilities. The first one is supportive excavation. When you're building in deep urban environments, you can't impact the neighbor's property, you can't impact the street. Imagine cars coming by winding up in the hole. So it's called an SOE design, support of excavation design. They need to tell you how you're gonna go into the ground before you pour any foundation, have no movement of any of the buildings surrounding you, support everything so that you can bring in your foundation and install it. SOE is number 1. The number 2 most important thing that a geotechnical engineer does is now forget about the design, forget about theory and thesis and hypotheticals. They are on the site monitoring the impact of what you are doing day by day, hour by hour, so that you minimize the impact of anyone around you, the structures around you, the people, the buildings, and the cars. So this is the first type of engineer where it's not just a theoretical math design, although there's probably a lot of math in it. They actually have to be in the field, another general in the field, guiding you through the process, making sure that your neighbors aren't moving, make sure you're installing it appropriately to not impact so that you can pour your foundation. So imagine if underground subsurface conditions can ruin your project, it can delay you months at a time. Who's the unsung hero who gets you out? That's the geo. Now, nowhere is geotechnical engineering more critical than high density urban environments. And that's why there's a soft spot in my heart. Because when I'm in the ground on a foundation in a high density urban environment, let me tell you one thing that happens every day: stress and anxiety. Because I can't have waking up and finding out that the other building is in my hole. So this is one of those things that you really have to pay attention to. But in New York, we have something quite unique that a geotechnical engineer has to deal with. We have something called neighbor license agreements, which is fascinating. You would think that your neighbor would want you to be building the building because it would add value to their asset when you're completed. Well, guess what? Not in NYC. We got something called NIMBY, not in my backyard, okay? Not YIMBY, yes, in my backyard. So what NIMBY is the next door neighbor being like, oh, you're gonna build here? Don't touch my building. Now, what's interesting is physics says the better I can actually monitor, touch, feel, and understand your building, the easier it will be for me to install and minimizing risk of your building. But that's not the way it works in New York. You need a neighbor license agreement to touch their foundation. In New York, we have to monitor the neighbors' buildings. How do we do that? We do that through vibration monitoring. You want it to be in the cellar of your neighbor's building. We do that also by crack monitoring, surveying their buildings on the XY axis. certain buildings can move, the geotechnical engineer actually maintains those data points as to how much a neighbor can move so that there won't be any type of critical structural issues. So when we get this license agreements, it needs to be designed what the impact of your neighbors are going to be. That also is your geotechnical engineer. So now not only are they not just theorists, they're now practical. Now they're politicians because they have to work with your neighbor to tell them how they're going to protect their property. So that is why the geotechnical engineer position is so important, especially in high density urban environments. Now, what do you have to provide a geotechnical engineer? Because as you know, in this game, when we're talking about the development pro forma, we always have to tie it back to cost, right? So what are some of the things that you do? What are some of the inputs that you have to give a geotechnical engineer, which you and I would call due diligence when we're going to acquire an asset? What you would want to do is to go into contract and be able to do certain testing. You'd want to do environmental testing, obviously, but what are the testing that matters to a geotechnical engineer? And there's two types of testing that we like to provide. The first one is a boring test. A boring test is drilling down, sampling per certain elevations, the type of dirt, the type of rock, and where the water table actually is. Why? Because when there's a certain density of the dirt, we know the load of the building above it that can be sit on that layer of dirt and not settle, meaning compress. The second thing is a test pit. What's a test pit for? I need to know the depth of my neighbor's foundation. Weights of superstructures and foundation are in a teardrop. That means that I cannot apply a pressure on a neighbor building. I have to be at the same elevation as the pressure of their building. A test pit allows me to see the neighbor's foundation, lets me see the depth of their footing so I can understand my SOE and structural design. So when we're doing our due diligence, there's two costs we look for, and that's borings and test pits. All right, as per our discussion, we always tie back to the development pro forma, but there's a lot of variability in the geotechnical engineering and underwriting it. So what line items do we like to break out so that we can mitigate the risk when we underwrite our project? So first is the cost of the engineer themselves, right? How much is that? Well, that really depends on a square foot number, a lump sum number, the complexity, the amount of neighbors, but usually I will put in somewhere between, I don't know, 50 to 75 G's on a 50 to 100 lot, and then I escalate from there depending on the depth of the foundation that I'm going to do. So first is a line item for your geotechnical engineer. The second thing, as we discussed, is the boring and test pits. So these due diligence items we also have to price. The next one is license agreements, which takes an attorney, and also is a time frame. If I'm going to impact my neighbor, I have to pay monthly for that option to be able to protect them or underpin them. So I put a line item in for that. And then the last thing is the monitoring. We spoke about that. It isn't free to have monitoring 24/7, especially when they're IoT, Internet of Things, and it allows you to monitor at all times to do that vibration and also to do the optical point monitoring for any type of settlement. All right, so those are the types of things. And then obviously if you find groundwater and whatever actually gets impacted below grade, you need to put that into your structural design and your structural costs, but we'll talk about hard costs at another time. So when you break it out, we got design, we got monitoring, we got legal work, we got cost of the license agreement, and then the final is just to have some type of contingency, because most likely, player, you're going to take too long and you're going to be wrong. And that's how we mitigate the risk in underwriting our pro forma for the geotechnical engineer. So if you want to be serious about development and you really want to get into the game, you're going to need to understand the basic idea, construction 101, that you have no clue what's happening below grade. So you need to mitigate that risk by doing a bunch of tests and having the right geotechnical engineer, which is part politician, part engineer, and part in the field practical player who's making decisions on the fly, and you need that experience. You also need to underwrite the categories that we stated. So as I was saying, this person, the unsung hero, the geotechnical engineer, can make or break your development pro forma. So if you're serious about developing, never sleep on the geotechnical engineer. And listen, at the end of the day, if you're serious and you're starting to enjoy these videos, make sure that you like, share, send it to your friends, send it to the people trying to get into construction, development, finance. At the end of the day, we're doing two things: capital advisory and asset management. We want to get you the money for your asset, and we want to assist you in the development process. Again, thanks for coming. Episode 3, that's in the bag, baby.